Now, if you see the combinational circuits, right? For example, in the SOP, we have many gates here, right? We have many gates. Also similar to the POS, we have many gates here. So when we have many gates, it means that we will increase the cost of buying the gates, and also it will increase the processing times. So how we want to make sure that we can reduce the cost of the circuitry, and we can reduce the processing time. So we need to have some techniques to simplify the logical circuits. So what are the techniques to simplify the circuits? There are three techniques here: the algebraic simplification, the Carnot maps or K maps, and also the Quine-McCluskey tables. For the K maps, we concern, or we this one can only cater for 4 variables of inputs only. But if we have more than 4 variables, we need to consider the Quine-McCluskey tables. However, for this chapter, we only concentrate on these two techniques, or these two methods only, which is the algebraic simplifications and also the Carnot maps. The first method for the simplification that we have learned in the previous slide, using the algebraic method. So basically, the algebraic method is very mathematics, and those who are not, and this is a drawback for the algebraic method for the simplification, because those who are not in mathematics, who are not expert in maths, and who are not familiar with the basic identities rules to do the simplification, they can do mistakes when they are doing the simplification. So another technique which can be used to simplify the Boolean equation is using Carnot maps or K maps. So basically, the Carnot maps or K maps is a convenient way of representing a Boolean function of a small number of variables. So basically, for Boolean function which has up or maximum to 4 variables can use the Carnot maps, but more than 4 variables, they need to consider the Quine-McCluskey tables, right? Now let's take a look at an example of the algebraic simplification, how we want to simplify the Boolean expression or Boolean equation using algebra method. Now we take an example from the SOP previously. So we have A bar, B, C bar, or A bar, B, C, or A, B, C bar. So basically this is the Boolean equation from the SOP before this. So this is the Boolean function of 3 variables using SOP. Right? So now how we want to simplify this Boolean equation, right? Using the algebra method. So this is the Boolean equation. And first of all, what you need to do is you need to write the Boolean equation. And then you need to do the simplification using the basic identities of Boolean algebra. Before this, in the previous slide, in topics 1, you have seen one slide that contains the basic identities of Boolean algebra. So you are going to use some of the algebra rules or basic identities to simplify the Boolean equation. So you have this equation which basically similar like this one, right? So basically this equation from the SOP. So we just write back this one, and from this equation we can do some factorization, right? So this one A bar B, and the second product term which is A bar B, so this one can be factorized. It's going to be A bar B and then C bar or C or A, B, C bar. And using the inverse law in the algebra, we can eliminate this equation, right? C bar or C, this one can be 1, right? Using the inverse law. So this one, after we do the inverse law, it's going to be A bar, B, or A, B, C bar. And here we can see that the same variables here, we can do a factorization again. So this one B, A bar, or A, C bar. And using the complement absorption theorem in the algebra, when A bar or A and something here, so this one can be eliminated. The A can be eliminated, right? So it's going to be B, A bar, or C bar. So this is the simplified version from the SOP equation. So this is considered as a canonical or standard form which has a long Boolean equation. And after we simplify, this is a minimal form. After that, after the simplification, when you got this simplified equation or the minimal form, you can translate this form or equation using the graphical symbol. So this is how you are going to draw the graphical symbol using this simplified equation. So when you see this simplified graphical symbol, this one is much more better compared to the SOP graphical symbol, right? Because this one you have lesser gates compared to the SOP that we have done before this. So this is the example of the SOP when you whereby you have several gates. You have 1, 2, 3, 3 AND gates, 3 NOT gates, and 1 OR gates. So after the simplification using the algebraic method, you can simplify or you can reduce the usage of the gates using only 2 gates, which is the OR gates, 1 OR gates, and 1 AND gates. And this one can reduce the cost of the circuits and reduce the processing time. Before this, we'll learn how to simplify the Boolean equation using the algebraic method. Basically, the drawback of the algebraic method is it is very mathematics. Those who are not into mathematics and those who are not experts and familiar with the basic identities, the basic rules to simplify the Boolean equation, they tend to make mistake when they do the simplification. So another way or another method to simplify besides to simplify the Boolean equation is using Carnot maps or K-maps. So basically, K-maps is a convenient way of representing a Boolean function of a small number up to 4 of variables. So if the Boolean equation has maximum 4 variables, they can consider the Carnot maps. But if the Boolean function has more than 4 variables, they need to consider another technique, which is Quine-McCluskey table. K-map consists of several and different number of cells. And this number of cells is depends on number of variables. If you want to draw the cells is depends on 2 power of n, whereby n is the number of variable. For example, if we have 2 variables here, 2 power of n or 2 power of 2 is equals to 4. So means that we need to have 4 cells here. If we have 3 variables, means that it should be 2 power of 3. and 2 power of 3 is equivalent to 8. So we must have 8 cells here. If we have 4 variables, remember that inside the chem maps we only have maximum 4 variables. So if we have 4 variables, means that it is 2 power of 4. 2 power of 4 is equivalent to 16 cells. So we must draw 16 cells here. For the 2 variables, we have about 4 cells here. And for the 3 variables, we have 8 cells here, right? And how we want to position the variable A, B, and C. So you have to remember that the most significant variable should reside at the row, and BC should reside at the column, right? So don't change the orientation of the variable, otherwise your answer will be totally wrong, right? So the row part should represents variable A, and for the column part it should represent variable B and C. Meanwhile, for the 16 cells, or we have about 4 variables A, B, and C, D. So the A and B should reside at the row position, and C, D should reside at the column position. So please don't change the orientation of the variables. All right. Okay, so how you want to determine number of bits for each of the cells inside the care maps. For example, this one AB, right? So first of all, you must start with 0, 0 because we have 2 variables, so means that this one should have combination of 2 digits, right? So we start with 0, 0, followed by 0, 1. After that, we move to 1, 1, and last one is 1, 0. Why we put the third cell as 1, 1? Because we want to have only one bit change, right? One bit change only. If we put here 1, 0, means that it's going to have 2 bit changes. If 2 bit changes, it's going to have more processing. When the processing time is increased, means that we are going to increase, or we are going to produce more heat, and this is not good for the processor. So we need to only have one bit change for each of the cells. So this one 0, 1 and followed by 1, 1. So means the bit change only from 0 to 1. After that, the last cell is 1, 0. So means that this bit, the second bit change from 1 to 0. So means that only one bit changes is allowed. For the 3 variables where it have 8 cells here, right? So the BC, the variable B and C, the what we call the bits is same with the 2 variables here. For the row part, variable A, it only contains 0 and 1, okay? Because we only have 1 variables here, and the possibility of 1 variables is only 2, which is 0 and 1. For the 4 variables here, all right, so this one basically same with the AB, the position of the bits, right? How to determine the bits for the row and for the column, right? So it's similar like the 2 variables. So we start with 0, 0, 0, 1, 1, 1, 1, 0 for the column part, and for the row part it's same. We start with 0, 0, 0, 1, 1, 1 and 1, 0. Alright, so you already know how many cells that you need for specific variables. For 2 variables means that you need to have 4 cells. If 3 variables, you need to have 8 cells. For 4 variables, you need to have 16 cells. So you already know how to determine how many cells for the determined variables. All right, and then you already know how to determine, right, how to place the position of the variables. All right, 2 variables, where's the position? For 3 variables, how to position variables A, how to position the variable B and C, and for the 4 variables, how you want to position the variables A, B, and how to position the variables C and D. All right, and after that you already know how to put the bits inside the cells, how to make sure that each cell has its own bits. So you already know how to put the bits for each of the cells, right? And the next one, what you need to do is you need to mark how you want to determine um, um, based on the canonical or Boolean expression here, how you want to determine or you want to mark, you want to label inside the K-maps. All right, so we take a look on the first example here. You have the Boolean equation, which is A, B bar, or A bar and B. So obviously from this expression, Boolean equation, you can say that this is a SOP equation, sum of product equation. Why? Because you end the term and you end the input and you or the term, right? You have term 1 and term 2. So you or the two terms means that this is a SOP canonical expression or SOP canonical form, right? So you have the first term here, which is A and B bar. So how you want to determine or how you want to mark inside the K-map. So this one, A, B bars, remember the principle of the SOP. For the A, it should represent 1 and B bar represents 0. So A 1 and B 0. So this one, it should be A 1 and B bar is 0. So this term will be marked inside these cells, right? And the second term, which is A bar and B, so means A bar is 0 and B is 1. So you need to find the cells contains 0 and 1. So this one is 0, 1. So you need to mark these cells as 1. Right, so basically the empty cells here basically is 0, but to reduce the confusion, right, you just need to put 1 here because this is the SOP canonical form or the SOP expression, right? So we move to the second example. This one, the expression is A bar B C bar or A bar B C or A B C bar, right? And this one also is the SOP expression, Boolean expression. So this one, how you want to mark inside the K-map. So this one, A bar is 0, B is 1, C is 0, C bar is 0. So you need to find cells which contains A 0, 1, BC 1 and 0. So A bar is 0. So this one you need to look at the variable A and 0 cells, right here, 0 cells. After that, you need to find cells which contains 1 and 0. So this one, 1 and 0, this term should mark inside these cells, right? Because this one 0, 1, 0, so 0, 1, 0. So it should mark inside this cell. The second term is 0, 1, 1. So you need to find cells which represents 0, 1, 1. So this one 0, 1, 1. So this term will be marked inside this cell in the K-map. And the third term, which is A, B, C bar, so this one is representing 1, 1, 0. So you need to find cells that represent 1, 1, and 0. So this one, 1, 1, and 0. So you need to mark inside these cells. The last example, this one with the 4 variables here, you have A bar, B bar, C, D, which means 0, 0, 1, 1. So you need to find cells which represents 0, 0, 1, 1. So this is 0, 0. After that, you need to find 1, 1. So this one should be marked inside this cell, right? So the second term is 1, 0, 0, 1. All right, 1, 0, 0, 1. So you need to find cells which represent 1, 0, 0, 1. So 1, 0 here and 0, 1. So this one should be marked as this term, right? And the last term is A, B, C bar, D bar. So this one represent 1, 1, 0, 0. You need to find cells which represent 1, 1, 0, 0. So 1, 1 is here and you need to find 0, 0. So this is 0, 0. So you need to mark this inside the care map. So you have 3 input here and you must label or you must mark 3 inside the care map. So basically the rest are 0, but we only focus on the 1 value only because this is the SOP. Alright, after we know all the basic things inside the care maps and we know how to mark all the Boolean expression inside the care maps, how we want to simplify the Boolean expression, right? So before we simplify the Boolean expression, after we do the marking inside the care map, we need to know several rules before we do the simplification. Before we do the simplification, we need to know the rules of grouping, right? There are several grouping rules for the care map. So the first one is the group may not include any cell containing a 0. So the first example here, this one, it contains a 0. So the grouping, we cannot group number 1 and 0 together. So this one is totally wrong. And this one is correct because this one, it only group number 1 only without grouping or include the cell containing 0 value. The second rule is group may be horizontal or vertical but cannot be diagonal. So for the first example, this one, it group using the diagonal orientation, and this is wrong. For the second example, this one, it's using the vertical grouping and another group using the horizontal grouping. And this one are correct because only use horizontal and vertical grouping, not the diagonal. The third rule is the group must contain 2 power of n cells. Means that it can group 1 cell, 2, 4, 8, up to 16 cells. Other than that, it cannot be grouped and it is incorrect. For example here, this one is correct because it group 1 cell here. And this one also correct because it group 2 cells. But this one is incorrect because it grouped 3 cells only. And this one, this mapping or this grouping is not correct. But this one at the right hand side here, this one is correct because it grouped 2 cells and 4 cells together. Rule number 4, each group should be as large as possible, resulting in as few groups as possible. For example, here at the left-hand side, right? So this one, it grouped 2 groups for 2 cells, which is basically correct because it's not violating number of cells here. it groups two cells together, which is correct, 2 power of n. But this one is not sufficient because we want to minimize or we want to simplify as many as possible. But if we only group right, two cells together, so this one is not simplified yet. No Boolean laws are broken but not sufficiently minimal. But at the right hand side here, basically the mapping is same, right? 1, 1, 1, 1. So we have 4, 1 together, and this one can be grouped as one group together. 4 cells as one group together, and this one is large compared to the left hand side here. Rule number 5, each cell containing a 1 must be part of a group if possible. So this one, if we have, for example, we have 1 here, but this cell 1 is adjacent to another one here, and it's already being mapped. So this one need to be grouped together as one group. So remember rule number 4, we need to group as large as possible. All right, so basically this one is not basically totally incorrect, but this one is not simplified yet. So this is the correct one, all right, because we consider grouping the cells as large as possible, and we are not leaving one value as one group only, right? Because we have the number besides this one, so we can group it as one big group. Rule number 6 is group may overlap. So if you see the example here, this is a 16 cells with 4 variables, and these are the mappings. 1, 1, 1, 1, right? And these are the groupings, which basically follow all the rules that we learned before this. However, this group, right? This group, we have one group here, one group horizontal, and another group vertical. So basically, this horizontal group is overlapping with these two vertical group. And when we want to do the simplification, we can eliminate or we can ignore the overlapping group. For example, this one, right? For this one, the cell containing ABD, right? ABD, this one can be totally eliminated because it is overlap with the other two groups. The last rule when we do the grouping is a group may wrap around the table. So means that this and the horizontal end can be wrapped together, and this and vertical and this and vertical can be wrapped together to do the grouping. So this can group with this one after it wrapped together, and this side, this value in the cell can be grouped together with this group of cell when it's wrapped together, and also this one when the vertical end of this vertical is wrapped together with this end vertical. So it can be grouped together. So this is the last rules for the K-map grouping. All right, now after we know how to develop the cells, okay, the K-map cells, and then we know how to place the bits for each of the cells, and we know how to do the mapping, and we know how to do the grouping, then how we want to do the simplification, right? So once you have developed the cell, you have determined the bits number here, you have done the mapping, and then you have done the grouping. The last one, you need to do the simplification, right? You need to come out with the Boolean equation which is simplified using the K-map or Kano maps. Now we can see that the mapping here there is two mapping here, one here and one here. So the mapping for the cell mapping is 0101, and another one, the second mapping is 01 and 11, right? So how we want to do the simplification, right? We only take the variables which has no changes, okay? For example, for this example, for the first example, which is the A, right? We can see that this grouping stay in the row 01, right? 01. So basically this one, there is no changes at all, because this grouping, this group only rely on one row only, right? But for the column part, okay, for the column part, you can see that there is changes, okay, there is changes for the bits, whereby this one 0, 1 and 1, 1. So 0 and 1 is changed, right? But 1, 1 is not changed at all. So how we want to do the simplification? What is the suitable or appropriate variable that we need to take, right? So now we can see that, okay, the first one, the row 1, right? The row 1, the variable AB, since there is no changes at all, because it only resides or it only relies on the row 0, 1. So we take as it is, right? We take these two variables, A bar B, 0 and 1. So this one means that A bar and B. But for the for the vertical parts or for the column parts, we can say that variable C is changed from 0 to 1. But for variable D, there is no changes at all, because it maintains 1 here. So we only take variables that there is no changes at all. For this example, 0 and 1, for variable C change, so we don't have to take the variable C. We only take variable D, which maintain 1 and 1 here. So this is the simplification for this mapping, right? The simplification, the simplified Boolean equation is A bar, B, and D. A bar, B, and D. We take only D because the bit no change at all. The bits maintain 1 here. We take a look another example, which is B, right? So this one is a wrapping table. Okay, this is a wrapping table under rules number 7. Right, so basically this one at this end and this one at this end, the bottom end, it can be wrapped together and it can form one group which contains two cells here, right? So this is basically the wrapping table, and the cells or the bit cells is, the mapping cell is 01 0001, and the second one is 1001. Right, so you already do the wrapping and you do the grouping, and you know the the bit for the cell. Now you want to simplify. How you want to simplify? Same like this one before, for the first example, right? So you need to take a look at bits of the variable which has no changes at all. So in this case, if we see at the AB variables 0, 0 and 1, 0, because this map is fall under 0, 0 and 1, 0. So we need to find bits that is no changes at all. So we take a look at the first variable, which is A, 0 here, and this one 1. So this one obviously it's changed, right, from 0 to 1. So we can ignore this variable A. For B, we can see that the bits is 0 and 0, which is maintained. So we only take variable B. Since variable B is 0, 0 here and 0 here, so we take or we put it or we write it as B bar because this is 0. So we only take B bar for variable B, right? And for variable CD, we need to see if there is any changes to the variables. In this case, since this grouping resides in the same column, which is 0, 1, so we take both variables C0, D1. So since C is 0, so we put it as C bar and we have D here. So the simplification of this K map is B bar, C bar and D. Another example, we look at example E here, right? So we have four cells 1, which is grouped together, right? And we can see that the mapping for the first cell is 0, 1, 0, 0. The second cell is 1, 1, 0, 0. Third cell is 0, 1, 0, 1. And the fourth cell is 1, 1, 0, 1. So these cells basically has been grouped together as one large group. And then how we want to simplify this grouping, right? So the same principle, we take a variable which has no changes at all. Since this is one large group, okay, so we can see that this group, okay, for variable AB, for this group resides under 0, 1, 1, 1, right? And how we want to take the appropriate variable or the correct variable, we take the bits or the variable which has no changes at all. So 0, 1 change from 0 to 1, and for B maintains with 1. So we only take variable B. Meanwhile, for CD variable, this group resides under 0, 0 and 0, 1. So we need to analyze which bits has changes, with which a variable has changed, and which variables has no changes at all. So C maintain with a 0, which is 0, 0, and D change from 0 to 1. So we can ignore D, we only take C. So for B variable, we write as B. Meanwhile, for C, since this is 0, we put it as C bar. So the simplified version is B C bar. Now we are going to look on the simplification example using K-map. So basically this is the Boolean equation from the SOP example from the previous slide, whereby it is A bar C, A bar B C bar, or A bar B C, or A B C bar. And basically A bar can represent 0, B represent 1, C bar represents 0, A bar represents 0, B represent 1, C is 1, A1, B1, and C bar is 0. Right, so how we want to draw or how we want to form a table, K-map table, we need to know how many cells that we need to form for the K-map table. So here we can see that inside this equation, it contains 3 different variables, which is A, B, and C. So basically, number of cell is 2 power of n. N is equals to number of variables, right? So we have 3 variables here. So means that 2 power of 3 is equals to 8 cells. So we must draw 8 cells inside the K-map. All right. Once we draw the cell, the K-map table, so we need to put the variables. So for the row part, we put A, and the column part we put BC. As I said before this, that you cannot change the orientation of the variables. So A is the most significant variables should reside at the row part. and BC should reside at the column part, right? So A only one variable, so the value should be two values only, which is 0 and 1. For BC, there are two values, so we must have two bits value for the cell. All right. So we start with 0, 0, followed by 0, 1. After that, 1, 1. So still remember that we only need to change one bit only, right? After that, 1, 0. So from 0, 1 to 1, 1, the bits change from only one bit, which is 0, 1 for variable B. After that, from this cell to this cell, only one bit change as well, from 1 to 0 for variable C. All right. So once we have done this what we call the cell, K-map cell, and then we determine the bits for each of the variables for the each cells. So we need to do the mapping. So we need to map for each of the product input, right? So the first one is 0, 1, 0. So we need to analyze the table which contains 0, 1, 0. So here 0, 1, 0. So map here 1, right? So the second product term is 0, 1, 1. So we analyze the table again. We find the correct bit cell, right? So this one 0, 1, 1. So this one should be mapped here. And the third term, product term, is 1, 1, 0. We analyze back the table and we find the correct cell 1, 1, 0. So another map should be inside this cell, right? So we have 1, 2, 3 mapping inside the cell. After we do the mapping, we need to do the grouping. And you need to know or you need to remember the 7 rules for the grouping. So we can group one as a one big group, and another one is one, another one big group here. So one group horizontal and one group vertical. All right. So once we have done the grouping, we need to find the simplification. Okay, we need to find the simplification. So for the horizontal group, one here resides or stay maintained at row 0 for A, right? Row 0 for variable A. So there is no changes at the bit, right? No changes at the bit at all. So we take the variables A, which is 0. So A0, it should be A bar. And then we need to analyze the column part, right? The column part BC, which are variables that we need to take, right? So since B maintains 1, 1, so we take variable B. For C, it's changed 1 to 0. So we can ignore variable C. We only take variable B because the bits maintain 1 with value 1. So the first grouping, the simplification is A bar B, right? For the second grouping, the vertical one, okay, the vertical one, so we need to examine the variables. For the A variables, it's changed from 0 to 1, so we can ignore variable A, right? For variable BC, we can see that this group maintain at column 1, 0. So we take this column, this bit, okay, 1, B and C, 1 and 0. Since C is 0, so we need to put C bar. We take B, C bar, B, C bar. So we have two grouping here, 1, 2, right? For grouping number 1, the simplified equation is A bar B. For the second grouping, the equation is B and C bar, right? So we can put the equation F equals to A bar B or B C bar. So from this example, right, for this equation, we can see the same variable here for these two products, right? B, and this second product also we have B. So this one we can do factorization. So we put B here and then we have A or C bar. So there is no other simplified or basic identities or algebra rules that we can use. So we maintain with B, A bar or C bar. For the simplified equation for the SOP example, this one, right? So for this example, for the simplified version, we can translate to the graphical notation or graphical representation. So we can see that A bar, C bar has OR operation. Meanwhile, B and this OR operation is connected with AND operation here, right? So we have A bar or C bar. So OR, this is the OR gates, right? OR gates. So we have A bar here and C bar here. And you can also put the NOT gates here, right? NOT gates here. And the second one, this OR bar is connected with variable B, input B using AND gates. And this is the AND gates, right? This OR gates is connected with variable B or input B using AND gates. So this is how you draw the graphical representation based on the simplified version or simplified equation from the SOP example. Now, if you see the K-map technique and the algebraic technique uh, produce the same results for the simplification as well as the graphical representation, right? So you can see the algebraic simplification from the previous slide. So this is the algebraic simplification. We have the simplified equation, which is B, A bar or C bar, right? And this is the graphical representation. This is the equation, simplified equation, and translate to the graphical representation. So same with the K-map technique just now, all right? Also produce same results, the simplified equation, and also the graphical representation. These are references that I use for this chapter from Stallings 2010 and from this YouTube. So you can read further, okay, you can read further to gain more understanding for the digital logic chapter from this textbook and also from the YouTube. So basically from this YouTube is more focused on the grouping rules. With that, thank you. Assalamualaikum warahmatullahi wabarakatuh.